Alright then, so these are the questions for programming techniques. Explain how, if you pause the video on when I get to the page, then you can have a go at these yourself. So explain how functions and procedures may be used to develop a program in a structured way. So, let's see, so what I get from that is you have to explain functions, then explain procedures, then combine them both. Oh, no. So each module can be written as a functional procedure, which can be tested individually. And then you talk about library routines, then code is reusable. Then main program consists of cells to functions or procedures which may be nested. So explain how functions or procedures may be used to develop a program in a structured way. So each module can be written as a functional procedure, and then they can be individually tested, but then again the program can use library routines, and then as the library routines they are already written, the code that is the new modules then can be reused at a later date. Then the main program will call the functions which may be nested. Yeah, it's definitely. Yeah. Alright, so discuss the use of functions, procedures, and stepwise refinement in developing programs. So it's 8 marker. So discuss the use of all these. So discuss functions, then procedures, then stepwise refinement. So I do the functions. So a function is. My mind has actually just gone blank. I can't even think what it is. Let's uncover it. Block of code. That's it. So you have functions. So a function is a block of code which performs a single task and then it returns a single value. It also uses the local variables. Then you'll talk about procedures. So a procedure, I would say it also does. I know it also uses local variables. Wait, can I ever do multiple? So a block of code which performs a task which may or may not produce a single value, which uses local variables. So first I talk about functions, then I talk about procedures. So a procedure is a block of code which performs a task that may or may not produce a single value. It also uses local variables. The next one is stepwise refinement. And I would talk saying stepwise refinement is where the problem is split into separate tasks so that some things can be written in different languages and to share and to be able to distribute it through a team. So breaks a problem into sections which become progressively smaller until each module can be written in as a single procedure or function. Each module can be individually tested, and library routines can be used. Oh, so I didn't want anything about having saying easy. So what I did the breaks a program into sections, which becomes progressively smaller. But then I needed to include the rest of it. So I needed to say, stepwise refinement breaks down a problem into sections, which become smaller and smaller until each module can be written as a single procedure. Then each of the modules can be tested separately, and with stepwise, you can also use library routines, so you know that they are already tested. You can also use library routines for stuff that is already pre-made and pre-tested. So explain some parameter. This is the data part in it, of something that can be manipulated by the function. Information about an item of data supplied to a procedural function may be passed by reference or by value used as a local variable. Oh, I got that wrong then. So explain the term procedure. It's an item of data that's supplied to a procedural function. It may be passed by a value or by a reference. It can be used as a local variable. The particularly high-level language uses local variables, global variables, and parameters. Discuss and compare the use of local variables, global variables, and parameters. So this is an 8 marker. So it's just saying discuss and compare the use. So at first you'll do the local variable, then global variable, then parameter. Then at the end of each one of those, or actually after those, then you'll do compare. So a local variable is something that exists within the scope of a subroutine that can only be executed within that subroutine. So local variable, a variable defined within one part of the program, and is only accessible in that part. I didn't say anything about execution, but accessible, that'd be the same. So data contained is lost when execution of that part of the program is complete. I did not say anything about that. The same variable names can be used in different modules. So local variable, local variable is defined within one part of the program and is only accessible within that part. Once that part of the program is complete, the data contained is lost. The variable name can be used in different modules. Now, global variable can be used throughout the thing. So, a variable that is defined at the start of the program. So, say it starts at start and exists throughout the program, including functions and procedures, allows data to be shared between modules, overwritten by local variables with the same name. So, a global variable. So, I'll have saying a global variable is defined at the start of the program and exists throughout the program, so it can be used within that program. I'm not really sure what it means by including functions and procedures. Oh, right, during, yeah, so a global variable is defined at the start of a program and exists throughout the program. It can be used in functions and procedures. It allows the data to be shared between the modules, but the global variable can be overwritten by a local variable if it has the same name. Now, parameter, I've already had this question, didn't I? And I've completely forgotten it already. So, information about an item of data supplied to a function or procedure. It can be passed by references or by a value, used as a local variable, so program can return correctly when procedure has been complete, or store return address, allow data to be transferred. So, a parameter is the information about an item, which is supplied to a function. It can be passed by a value, and it can be used as a local variable, and it allows data to be transferred. Yeah, I'll probably get about 6 marks for this question if it comes up. State the type of data structure which is used to handle procedure, calling, and parameter passing. State the type of data structure. Oh, yes. It is a stack, and the next one is also, so it is a stack, and these are from different years, but the questions are worded differently. So the next question is, state what data structure is used when procedures are called during program execution, and it's also a stack. So you can see it's different wording, but it's the same thing. So now state the purpose of using this data structure. So this question, you'll probably only actually get it right if you get the correct type of data structure. So the purpose of a stack is saying about programs can be executed in order or so. So programs can return correctly when procedures have been complete, or store return address, allows data to be transferred. So the purpose of using the data structure is so that the program can return correctly when a procedure has been complete. It also allows data to be transferred. And there's 1 mark though, so yeah, probably have to get both of those, wouldn't you? State the need for the BNF, so the Backus-Naur form. Oh, the need. That's to show order or something, is it? Oh yeah, to unambiguously define the syntax of a computer program. Unambiguously define the syntax of a computer language. I completely forgot about that. And yet I saw this question. Well, I only made the PowerPoint a couple of minutes ago. Well, 10 minutes ago or so. In a large company, each employee is given a staff code. Using BNF, the definition of a staff code is the digit, then letter, then staff code. So letter and digit, or staff code, then digit. So that can mean that it can be a letter, then digit, then another digit. State how the rules have been broken by each of these invalid staff codes, A2C and G45. So A2C, that is invalid because the C cannot be there. So A2C is invalid because the C cannot be there. Then for the G45, the G is not valid because it is not within the... I'm trying to think of scope, but that's not really the correct word. It's not defined, I say. So G is not defined. Oh, yeah, that's correct, yeah. A2C, only one letter allowed. One letter must be at start only. So we've got to say that. So yeah. So A2C, only one letter is allowed. Then G45, then you say G is not defined as a letter. So I got actually that right, yay. In a large company, each employee is given a staff code. So this is the same as before, but the difference is that after changes in the company, it is decided to allocate new codes. Write a definition for new code, which has one or more digits followed by 0 or more letters. For example, 1234 and 38B are valid, but A25 is not valid. Oh, yeah. So this would be the new code. Where am I? There I am. So I'd say that it would be the staff. I'm just going to rewrite over this thing. So it'd be the new code. Ooh, let's do this down here. Wow, I shouldn't really be using the mouse, should I? Oh well, it works very fine or whatever. So new code, and those would be within those things, those arrows. I cannot even remember what they're called. Then you've got the colon, so it's defined as. Then you're going to have a digit. Or actually, I'm going to do that. Digits. I've spelled that wrong, haven't I? Digits. So digits. So it can be that, or it can be. Should I do digits there, or should I do new code? I'm going to do it like that when it ends up there. So I'm going to do new code. I know I spelled new code once. Oh well. Those would be all in capitals though, as that is in capitals. So if I do it like that, then you're going to have a letter or letters, and that would also be in capitals. But I'm not doing it in capitals because I'm not that great at using the mouse. So let's go back to. Let's point. There we go. So let's see if this is correct. So. Oh, right, they wanted you to do it all. You may assume that digit and letters are still defined as earlier. So you could probably get that, though. Oh, they've done that as digits. So for... Oh, where am I? No. So for this bit, let's do pen, ink colour, let's do blue. So that needs to be the digits instead. So digits can define correctly, letters define correctly, and new code defined correctly. So I guess I would have got this, sort of. But then again, that would mean that I could have... Yeah, that should mean... Oh, yeah, that would mean that I could have the... Yeah, so if it's like that, I could have had the new code to be like 3. So 3 from there, then... Yeah, so make sure that is digits. Let's change that colour back to normal. It's red. Let's turn off laser pointer. So what you have to do, so you may assume, so I'm not really sure if you'll get all the marks if you just did that. So it is a good idea. Yeah, it's a good idea if you do define the digit, then define the letters. Oh yeah, because that's different, isn't it? So yeah, you will have to do all of that. So you have to just do the same thing. Why is that digit or digit? What? Oh right, yeah, that's what digits equal. So yeah, you have to define that. So those would be the same, but you have to say what digits would mean. So digits would be either 1 digit or 2 digits. Letters will be either 1 letter or letter and another letter. Well, letters. And then the new code will be digits or digits and letters. So, yeah, I won't give my mark. I'll probably only give myself... Yeah, I wouldn't actually give myself... Actually, yeah, I'll probably give myself 1 mark. But that is just a push, because I should have done digits. Let's go on to the next one. So, for particular programming languages, The following features are defined. Digit is a single digit, 0, 1, yeah. Letter is any single lowercase letter of the alphabet, A, B, C to Z. A syntax diagram shown below is used to define a variable in the language, so percent, letter, then it can be a digit or it can be another digit. So for each of percent %xy2 and percent %34, give one reason why the expression is not a variable. Huh? Oh, right. Oh, yeah, I got it. It's because there are two digits, so for percent %xy2, there are two letters, and for the percent %34, there needs to be a letter. Yeah, so percent %xy2, only one letter is allowed. This has two. Percent %34, the letter is missing, there must be one letter. So you could probably just find saying only one letter allowed and then saying letter missing. With the help of examples, explain the difference between the following definitions of identifiers. So these are the identifiers, so $, digit, letter, and then another letter, well, or it's a loop, then $, digit, or $digit, then letter. So identifier A must include one or more letters. Identifier B means not include any letters. Oh, so you must do it like that, just say what it is exactly. So one or more letters needs no include any letters. So identifier B does not need to have any letters. Or identifier B does not have to include any letters. For example, so if you give an example, that'll get you 3 marks. So %2 is valid for B, but not valid for identifier A. But $2AB is valid for both. Yeah, because AB, that's multiple letters, since that can go in a loop. State the purpose of a syntax diagram. That I've completely forgotten. To show purpose is... Oh, is this like saying unambiguous? Yeah, unambiguously. Yes. I think this has come up there before. So, that was for BNF, the purpose of BNF. So, purpose of syntax diagram, to define terms unambiguously for a computer language. Give the correct name for another notation that can be used instead of syntax diagrams, and that is BNF, so Backus-Naur form. Do not actually say BNF, because that is the what's it called? The abbreviation. So do not use the abbreviation. Use this exactly, and try and spell it correctly as well. Draw a complete set of syntax diagrams to show label. Where label is single letter chosen from A, B, C, D, or E, followed by the symbol times, well, star, then any number including 0 of digits from 0 to 9. For example, A star, then B star 3, and C star 456 are labels, but F star, I'm just going to say time, star, so F star 7 and D, E star 7 are not labels. Okay. So draw a complete set of syntax diagrams. So this would be when you're doing it like this. So 4 letters, you've got to label it correctly, so letter. Then you've got to make sure you include this arrow. Let's actually go to the laser pointer. Yeah. So you've got to make sure you include this arrow, and then it goes into each of these. Because if the arrow wasn't there, you just go straight through to C. Then you would probably just go back round and then into some more. So make sure the arrow is there. So the arrow would be like you hit a rule and you've got to decide which way. So it's a decision type thing. Then make sure that the arrow is out like that. The layout of this, so the circle, then the lines like this. Just make sure though that you have it correct with including that arrow there. So the next one would be the digits. So you'll do it the same way, but change it to digits and add the correct amount of lines, and make sure you include the arrows again. Then the next one would be actually making the actual number itself. So it would be the letter, so an arrow, so then letter. Let's actually draw it, yeah. Let's draw it. So letter, it would be, sorry about this really bad drawing, well, writing, I'm trying to use a mouse. I could get my tablet, but I can't exactly, don't really want to mess around with that. So digit, then it's the star, then it it can just end like that, or then it can just go backwards to have a digit. Try and make sure though that your lines are. Let's keep on pen. So make sure though that the. So let's see. Oh, I've just written right over the top of that. Well, you can still kind of see it. So that's what I've done, and that is the correct way. So let's actually just erase it all in on the slide. So you've got to get the label correctly. Make sure though that the needed to include. Did I include that in a circle? I think I did, didn't I? So make sure the arrow goes out like that, but make sure the digit is on like the loop area, the arrow that goes back on itself, because you can have a valid thing. So yeah, so you can have multiple letters, then a star, then no digit, or you can have. That's not a. So then you can have a letter, so only one letter you can have, then a star, then nothing, or you can have a letter, star, digit, then you can have another digit, then you can have another digit, and so on and so forth. There might be like a cap as well, but well. So the system uses the following definition in BNF. Okay, so PQRS 0 to 4. Code is alpha digit or alpha code. T3 and PQ23R are not valid codes. From the definition, show where the rules have been broken. So you've got to explain. So you've got to say, so T3, that is invalid because T is not defined. Let's say defined? Or is, yeah, so I'd say, so T is not, so for T3 is not valid. Then for PQ23, the R is invalid, is it? So T3 is not in so T is not an alpha. You've got to say exactly where it is. Then PQ23R, only one digit is allowed by the definition. So it can. So where would you add the? So the only way that would be actually kind of legal. So only one digit is allowed by the definition. So that would probably be different if you had it. So it could be alpha, then code, or then another digit after or so. Use the BNF definitions form to write a definition for number where number has one or more digits. One or more digits. I'm just going to reveal this. So number. Oh yeah, you're doing it like that, aren't you? So number is defined as a digit, or digit, then a number, or alternatively you could have done the same thing at the start. So number is defined as then digit, then you could have just got the number first, then the digit. Draw a syntax diagram to represent the definition of identifier where identifier has one alpha, then one digit, followed by at least one code. Note you do not have to draw diagrams for letter, digit, or code. So, the identifier, the identifier has one alpha, so I'm just going to call it ID, and this should be in a box, then one alpha, so I'm just going to call it A, but you will have to call it alpha. Then this, so then one digit followed by at least one code. I don't. Oh, right, yeah, I didn't need to include ID. So you need to do the letter, so alpha, so change alpha to letter, so letter, then digit, then it can be the code within that bit, but then make sure you include the loop. So the marks will be awarded for definition of the label, so represents the definition of identifier, then 3 terms in the correct order, then you have to complete the loop around code. Oh, so the main thing, so this is the label, and then this, where is it? That is the letter, that is the digit, and that is the code. So where it says at least one, it means that it can have more than one, so include the loop. The binary tree shows operands P, Q, and R with operator minus and times. Obtain the reverse Polish form of this expression. Okay, so let's see. So you start at the root and you go down. So the first one is P, then go down, then down, and down. So the next one's Q. Make sure though it's all probably like lowercase as well. So it goes down there, then it goes back up, then down, then R, then up, then times, then back up to minus. Let's see if that's correct. Yes. Any expression starting with P and using only the terms provided, so PQR times minus. Yeah, I got that correct. Yay. State the type of traversal that should be used to obtain a reverse Polish form for a binary tree. This is for a binary tree, that's the post order, isn't it? Post order? Yeah, post order traversal. Pre-order is when you put it on to the binary tree. So that when you want to obtain if you're putting the Polish form onto the tree, that is the pre-order, then the reverse is the post-order, because it's after and stuff. Right. An expression in inverse Polish notation is TU times V plus. Show how you obtained your answer. Evaluate this expression. T equals 2, U equals 3, V equals 10. I'm not sure. So T is 2. Oh, is this solving it? Oh yeah, answer. So you need to answer it. So maybe 2 times. So that'd be T U. So T times 2. I think that's it anyway. So you do those lot, then you add that on. So that is 6, and then you add on the V, which is 10, which gives you 16. Yes, multiply T by U. Oh, why did I do it in that place? So multiply T by U to obtain 6. Yeah, that's what I did there. Obtain V to obtain 16. So that's the answer. So they want you to solve it. So the way you solve it is by doing the TU first, then the V plus after. So anything before that, yeah. State what data structure other than binary tree may be associated with reverse Polish. And that's a stack. If you've noticed on the video, I did actually include a stack within that. So a stack, that would be when you have the stack and then you'll just put it on. So you'll put on the T and then the U. And then you'll take those off, you'll put the value back on. So T is 2, 3, and you put on 6. Then you'll put on the 10, and then you'll add those together, and then you would just put on the, you add those together, then you put the result back onto the stack. So that is how you actually solve that basic one from there. So 3, you'll put 2 and 3 on the stack. Take the 3 and 2 off the stack. You've got to multiply those, and then you've got to add these two together. So add 2 and add 10 and 6 together, which gives you that as 16. So state a symbol often used in mathematical expression that is not required when working with reverse Polish notation. Ooh. State a symbol often used in mathematical expression that is not required when working with reverse Polish notation. It is the brackets, because the notation already knows what needs to be done first. So binary tree shows operands A, B, C with operators plus and X. Obtain the reverse Polish of this form using post-order traversal of the tree. So before we said that was pre-order, which you put the expression onto the binary tree, and post-order is when you get it back off. So let's solve this. So you go all the way down, you start a root, you go down to A, then B, then times, then C plus. There you go, let's see if that's the correct answer. So, yep, AB star, well, times C plus. And you just basic way to remember this is you go around the outside. An expression in reverse Polish, an expression in reverse Polish notation is FGH. Thought that was the same from before then. So expression, so FGH times plus. Show how a stack may be used to evaluate this expression when F equals 3, G equals 4, and H equals 5. So I did actually mention this before when we did the first one. So if I just do this, so I'm just going to do it to the side. Hopefully this doesn't get overwritten or so. So you'll put 3, 4, and 5 on the stack. Oh no, I know what to do. You will put the G and F on the stack. So you put 4 and 5. Then you would times them. and then you'll put the answer on here. Oh, so you've got to do the answer as well, so that's 20. Ah, look at me doing, oh, let's make sure it doesn't look like 26, so that's 20. And it would be good though if you actually shown what it is, so for 20 you'll have to show it is 5 times, well that doesn't look at times, times 4, and make sure it's those in brackets just as a note as well, so, get rid of that after bracket, so equals 20 then, yeah, so a bit more about 20, so just do the 5 times 4, then you would keep the 20 there, but you would then add f, which is 3, and then you add those together, so it would be 3 plus 20. 3 plus 20 is 23. See if that's correct, yes. So, oh, you're meant to put f on first. So, what it is, so, you have to put, so you do f. Oh, so f is actually still on there then, is it? I thought f you'll put it on a bit later. Oh. So is this like on, I think this is the, oh, stack, yeah, stack is first in, last out. So it is a good, that is why f is there, because you do that last. So you put f on, then you put g on, then you put h on, then from that you do h times g, which gives you the actual 20. F is still there though. F is still there though. I accidentally went backwards. Then you take both the 20 and the f out, so the 3, and then you do the f plus 20 is 23, then you put that back onto the stack. Oh, I'm surprised that they didn't actually put the value. Show how a stack may be used to evaluate this expression. Oh. So they were after it just so they can easily fill in the result with anything else. So you could probably do it like this. So you could do like 3, make sure it looks like it's like you can do that yourself if you want, like just to remind you if you want. But it's not exactly required. Only the stuff that is only required is the f. So I wouldn't actually do that actually. So just do the value itself. Do not do the number value like I did up here. Do not do that value. Make sure it's f because the question actually says, show how a stack may be used to evaluate this expression. If it wanted you just to enter the 3, 4 and stuff, it would say, show how you got this answer, it would probably be. State one advantage of reverse Polish notation compared with usual infix algebra notation. Doesn't require brackets. Oh. Any expression can be processed in order, so from left to right. No rule of precedence are needed. No brackets are needed. Also, I kind of got that then. And unambiguous. So, one of the things that I would say is that, so one advantage is that there are no brackets needed. So that's what I'll say, just no brackets are needed. A binary tree shows operands P, Q, R, S with operators, times, and plus. Obtain reverse Polish of this thing. So, reverse Polish, so that is going to be used in the post order. So you go down this way, so you'll get P, then Q, then plus. So you add those together first. Then you'll get R, then S, then minus, then the times. So, oh, I've actually already said the answer, and oh well. So, PQ plus RS minus square thing. So, PQ plus RS minus times. So, any expression starts. So, if you didn't get that correct, the only mark that you'll get if you've got expression starts with PQ, then you'll probably get another mark. So, you'll probably get 3 marks if you got it wrong. Like, if some things were correct. So, the only thing is if you missed out the times. The correct name for this type of tree traversal is the post order, I said before. But if you're doing this page, if you're having a go at this yourself, you would pause the video before. Alright, so thanks for watching the video. The next set of videos is on the low-level languages. Tonight, though, I might go through a paper. So if you see, there's the. Oh, I need to tick those off, and I've planned it. There we go. So, low-level languages, I've already planned them, but I've just got to record them, and those, I will try and get them up today. If not, I'll try and get them up first thing tomorrow. And then databases, that will actually be tomorrow because I've not planned any of that yet. Tonight, though, I'll go through the January 2010 paper.